In the lab number 2, we want to study the falling objects. For this time, we use the theory of Newton's second law. Now the video motion capture and data from tracker. We want to use a plastic tap to drop with initial velocity equal to 0, and we obtain this data from tracker. The velocity observed is constant in the last 3 points. This makes me think about a terminal velocity, but let's see what happened. When an object is dropped, its initial velocity is 0, however, accelerates due to the interaction of gravity pulling the object toward the Earth. In this process, the amount of force is non-zero, therefore no change in the velocity. However, not only the gravitational force affects the object, the drag force influences the movement speed is proportional. Addition to velocity, the drag force depends on a constant v, which is related in the geometry of the object. Using this velocity, I computed the data of 0.0052, but something is different with the model experiment. This could indicate that terminal velocity is not 4.326 meters per second. All the physics is putting in the programming data page. Now when we put v equals 0 in the Python files, we observe the following situation. Running the program, and only a yellow arrow indicates the weight, but not else. Now in the next situation, I put drag force proportional to v squared. This may indicate to me how the program is running in this time. We see the blue arrow indicating the drag force. In the next situation, the drag force is not proportional to square v. It's proportional to v magnitudes, and this is a result about the running the program. Again, the yellow arrow represents weight, and the little blue arrow represents the drag force proportional to v. When we make a plotting of this result, we have the graphic who describe a movement or parabolic movement, and we see, you can see, the position versus time. The red line is a model position, in the blue dots the experimental position is a little bit superior of the model position. As we can see, there is a movement with a drag force depending on the laminar flux, not a turbulence. Watching the graphs. In this figure, laminar flow consists in this way, and the laminar turbulence flow consists in unorganized motion. Now, what if we put initial velocity equal to 5 meters per second? Well, the result is the next chart: position versus time, and the movement is still a parabola, but more linear. In summary, there is a drag force that affects the motion in free fall. This force can be laminar, our case, or turbulent, affecting the speed limit that make the net force equal to 0.